Welcome everyone to another live stream of Civiltechsource. In this tutorial, what we're gonna be doing is one of the viewers commented like how can they rotate their drawing so it can fit their paper space in the way they want, obviously, because all you can do is just go the next size up in paper. But let's go over it. So basically, let's assume that we want to rotate this layout so the building line is parallel to our viewport, so basically our bottom line. So if we draw a rectangle around it, let's put it this way, we want to make it to be parallel, so that way. So I'm gonna show you my way, which I believe is the most sustainable way to do these things, because what will happen is in the course of your drawing life and going through updating extras, etc., you will have to go through updating stuff. So you want to make it sustainable and not cause problem to yourself. You might not cause problem to yourself, but you might cause some confusion, let's put it this way, to your colleagues. So we go to model space. What we're gonna do is now we need to understand how we want the drawing to pop out. So to do that, we're gonna go to paper space, draw a rectangle over the viewport, and then we're gonna select a rectangle and we're gonna use the change space command. And then we're just gonna double click outside the viewport. And we brought our rectangle in model space. So basically this is 1 in 500 how will be print in, what size was it? And A1, I think. Yeah, A1. Then what I'm gonna do is, because since I said I want it to be parallel with the face of the building, I'm just gonna draw a line over the face of the building and then move it all the way to the corner so I can rotate it. Now, before we rotate, we need to understand a few things. You have a Y and X here. Now, I wanna keep it that way. So basically, I wanna keep Y always facing up and X facing to the right. I don't want it to deviate too much. So I'm gonna bring my north here so you can see it as well. And I'm just gonna look at the coordinates, 452,000 and 433,000. So what I'm gonna do now is just use the rotate command. Let's rotate. Oh, it's not exactly where I wanted. So let's move it back to where it is. And then let's use the rotate command. And then what I'm gonna do is just find the middle point and then try to align it in the middle. There we go. So now what I'm gonna do is I'm gonna use the UCS command. Now the UCS, what it is, so if we go to Google and check, UCS basically is the movable Cartesian coordinate system according to Autodesk. So basically what we're doing is moving our 0, point to where we specify it is. And now what I'm gonna do is you see the Y and X shifted and it's now on my cursor. It's no longer at the bottom left of the screen. So I'm gonna move it all the way to here. And since this was, let's say this side was the 0 degrees of the circle, if you remember from high school or when you were doing math, what I'm gonna do is start moving upwards. And that's where I want it to be. And you can see now my Y, it gives me the option if the Y should be up or down. I want the Y to be up and the X there. You can see the north didn't change much, right? Wait for it. So if I now go and bring a new north block, that's where my north is now. But that is not correct because my north is always that way. It has been that way. That's how the drawing's been. But the UCS changed. So this is the correct north, not the north that you bring afterwards. Now, the next step is to bring UCS and then type NA for named and then S for save. And we're gonna save this UCS option as option 1. The reason we're saving it as option 1 is because when we type UCS, we can always go back, name, restore, and we can just bring it back and type option 1 and restore it. So let's say UCS and we go back to world. So that's the true coordinates. So it's back to 452,000, 433,000. If I type UCS and then named and then restored and we type option 1, it'll bring it back to option 1. So it always stays there. So now what I'm gonna do is go back to paper space double click on my viewport, type UCS, and then NA for named, and then R for restore, and then type option 1. I don't usually leave names in my UCS naming. The reason being is I don't know when AutoCAD is going to be funny about the space thing. So I type option 1. Now you can see the cursor has changed. And what you will do is type plan and then select current UCS, or just type CU and hit enter. You can see your drawing has rotated, and the true north now is showing exactly where the true north based on the rotation of your drawing. Now I'm gonna keep it 1 in 500, so I'm gonna use my command to delete all the scales and put the meter scales again. Double click in the viewport and change it to 1 to 500, and then bring it in over here. And now I can make my UCS back to the world, which is the correct one, and everything is true coordinates, and everything is shown here as it is. Now the problem with this method that we haven't finished yet, the problem with this method is when I bring the finished floor level and I bring it this way, and let's say that's how I want it, because that's my UCS, that's the true world. When I go to paper space, it pops up like that. Now the only fix to this is to, when you're work in the UCS that you're showing in the viewport, when you're basically only when bringing blocks, because that way the blocks will come to the right rotation. So as you can see here, or let's say do the proposed level block, you can see it comes to the right rotations. But if we had it in, let's say, UCS world, the blocks would have come like this, which is not what, if you're like a alignment freak, then you don't want it to come like this. You want to come it like, let's say, horizontal. So that is why I save the UCS, so I can switch between them. So now let's say we have detached the XREF of the topographical survey. Now if we go back and bring it in while we are still in option 1 UCS, what will happen is the XREF will not load in the right place. Why? Because the UCS coordinate system, basically the settings, do not match the ones of the topographical survey. See, it will bring it over there, which is the actual dry coordinates. So what we will have to do is detach it, then go back to our drawing, change the world coordinate back to UCS, change the UCS back to world, and then attach the drawing topographical survey. Hit OK, it comes in right coordinates, and if you want to go back on it, just hit option 1. Now what I usually do is I always, before I close my drawing, I bring it back to world, and the reason I do this is so for my colleagues, when they're not aware of the UCS, or if they don't clock that the UCS was not set in the right coordinates, they can, when they XREF and change drawings, it will come in the right place, and they'll be like, huh, why did it end up there? So always have a save practice. You can always have like create a macro for a save button, so when you save and close the drawing, it changes the UCS back to world, so that you can do that. I think the command would be UCS and then world. That's pretty much it. So in the macro, just type UCS world. And yeah, that's it for today. The reason I did this live stream is because one of you guys commented on it, and because it will take twice as long to create a video about it and edit it and upload it, I decided to do a live stream just to make it give you the answer quite quickly, and then further down the line I'll create a proper video on it. So if you have any questions, post them now in the live stream, or I'm shutting it down. Actually, I'm gonna shut it down. It's quite late. I'm working tomorrow. I'm really tired. So stay safe, and I'll see you in the next tutorial video, which will be the UCS. We're just gonna do a tiny bit more in depth. We will cover the same aspects, but if you want the quick answer, this is the quick answer.